Yeah. One classroom was different, and then all of the private stuff based on this. So like that was a little and then like my third grade also asked about these things. Right, which is what I was saying.
Matter. But it's made out of matter. Different. Kind of like a little bit of everybody, like, and like building on one. Yeah.
So that was three. It's very confusing. So sorry. All right. That's why I'm here today. Well, yeah.
Okay, alright, sounds good, thank you.
Oh, that's right, not this week. That's right. So I don't know that necessarily she didn't answer. Right. It's pretty much bad to like put her phone down and not answer phone. But I haven't heard anything on it, so I don't know. The finding was right. So, but I think that's why I'm doing
Nothing you can do.
Okay.
That I know.
Dad had to be very careful with the baby, that my sister has a baby that's over the line. It's not that true.
I just try to keep my hands out of it.
Really? You just have to, really be cognizant of that.
Yeah, try it. And kids that are sick, I send to the nurse's office. The nurse and I have an agreement.
Dr. West, the lab tables that I see stacked up in the hallways and whatnot, are those going back into a classroom? Okay.
There is an auction of things that we get rid of, that the university has, I think, twice a year. I can find out what the dates are.
Okay, because these would be great in the classroom.
Yeah.
It would be much better than, I like the tall ones that, I think that was one of the reasons why when we had the lab, it didn't get used.
So they were tall.
Well, can you imagine a 5-year-old trying to climb up on those stools?
It's not a kindergarten lab.
Well, when we had the lab, it was for everybody.
For everybody. It was built as a 5th grade science lab. Now, I don't agree with that, but
Right.
that's a reality of it.
Right.
So, I mean, kindergarten should be doing science and they're learning. Every teacher should be doing science and pretty well as math.
Right.
They do not need a lab. In fact, Denise and classroom should have restrooms.
Mhm.
And, you know, we talked about loss of instructional time with lining up to go to the bathroom.
Mhm.
But even if you've got a fifth grade lab, I mean, you've got 5 fifth grade teachers, you can't go in there 60%
Right.
of the time, you should. You've got to do it in the classroom.
I think these would be great. I love the tabletop though.
Well,
If I could put, they're
they're
expensive.
expensive, yeah.
Right.
Yeah.
The slate, because the ones, the black tops we had, I think it was still just a black Formica that was ever so slightly tougher than the plain laminate.
Now, we don't recommend this.
Huh?
We do not recommend them take away paint.
No.
You've got the electrical outlets.
Yeah.
It needs to fit,
You know, with the reprieve. This room has, lab counters around the edge. Need electrical outlets.
Which y'all even talked about. But that's okay.
Right.
Flat iron it, or does it just do that? There'll be some time before school starts that you can go through all this with me. Not even today.
Yeah.
again, right before.
One's up.
There's allocation.
Fifth grade, you won't even have 15 minutes.
Yes.
That's my second.
So we're going to make it on I don't know if Reed will be.
I can't find. Whenever I was a teenager, you could just find out this is a sad years old technology. I just can't find stationery. You own Half Price Books, it's the only place you can get it. But even then, it's barely just notepads and cards. You can find like stationery.
Target sometimes.
Oh, really? Stickers.
On the Reading Academy.
Oh, that's right. It might be. I used to hang out there when everybody was a kid. Because it was big. It was the two stores.
I mean, it's a nice one. We would all get together, see.
Shiny and like I was quite big and active.
Blah, 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 blah.
Need you to get cereal for breakfast, like little sugar cereal. Well, the only time we use it is in our classroom
Somewhere, I bet those
for
yeah, and I feel like I had all of my favorites at one time, but yeah, I do
If I feel like having a drink, like a sugary drink, have one, but I have another one. You're trying to fruits by any bar. And I was hoping to find out the next week. I have yeah, that's what I was saying. I'll be on a diet,
Yeah,
but on the fourth diet.
I mean,
I for like 2 days, and then the third day I'm on diet. So, yeah, it would be different if I was like junior high, like getting used to eat a bit of cake.
I mean, she's super.
But this is second grade where I have an entire classroom and all 4 subjects to plan. I was for 7th grade science. Or even 7th grade in science inclusion at the junior high children, and I have to get
Okay, guys. Still sitting about 30%. They work? No, we're still waiting for the Thank you for asking.
You dropped something.
we're missing 4 people. Anybody over here? Okay. Somebody just go ahead, yeah? Now we're down to 2. Brandon.
He's outside, so we might as well just go.
Okay, we're gonna go ahead. All right, now we're gonna take those definitions that you talked about during hand up, pair up, stand up, hand up, pair up. If you need to edit your definition according to the discussions that you had with your colleagues, go ahead and edit those definitions right now. We'll take 1 minute to make sure you have written your thinking.
He always writes.
You gotta say complete sentence.
One single type. Because this is one type of element.
That's why it's one.
What do y'all think? Just as. Molecule.
Okay, put the finishing touches on your writing.
Different.
Now, we're gonna do something called one stray. Here's how this works. In your group of 4, or however many, 3, 6, let's see, I want you to discuss who has the most pets in your household. Not children included.
Children
Yeah.
included, not
Not children included.
do the same line.
I have one. Okay.
Bingo.
In a tie, if you have equal numbers, look at what you're wearing. The person wearing the most pet hair wins. 5, 4, 3, 2, 1. If you are the winner of your group, would you please stand up? All right. Now, winners, you are the one that is going to stray. You are the one that will stray. And we're going to go counterclockwise, and you're going to move one group counterclockwise to you. Okay?
I've done that before. It's really
So go ahead and move. This is counterclockwise. So, okay, sit down. Now, you're gonna do 2 different things. You're gonna discuss the group of 3, you're gonna remain silent. The new person, the stray, is going to share their definitions. Then, someone from the group of 3 will share your definitions. And then you're gonna come to a consensus. Go. Stray goes first.
Atom is the smallest amount of matter that has the properties of substrate. A molecule is another particle of a substance. Oxygen matter in
Okay, so you said, atom, repeat your definition.
makes molecules and atoms make
Yeah, you should.
Do you want to share for our group?
Thank you.
Yes. When I also elements, but also molecules. Because more than one has multiple atoms or atoms. also a molecule or a compound because you have different types of elements.
So do you want to maybe start putting together your thoughts and words? You've got 3 different perspectives.
Sure. Right now, really, I'm just listening and trying to figure out what they're saying. So, you want atoms one element? An atom is just elements are made up. I think one atom is the smallest substance. Like this is an atom of a coal. This atom is the same particle of one different.
And it's still the same
An atom is the smallest
building block.
amount of matter.
Because if you start breaking this apart, then you start breaking it into
Okay, after you come to a stopping place, straight, go back home.
Stray, go back home.
Okay, Stray, now that you're home, share with your group what you learned at the place you visited.
The orphanage.
And then, listen please, you're gonna do the same thing you did in the last round. Stray, you're gonna share with your group what you learned, or what edits you came up with your definition. And then the existing group of 3 is going to do the same, what they learned from this stray, okay? Go.
Just the
right.
and then ask me the question made up of
Wait, atoms of the same thing or atoms of different? She kind of like predefined them.
See, I would say compounds are like, you've got your pure elements, but
Okay.
compound.
You can edit your definitions, write down your questions if you have any.
This isn't a molecule, this is a molecule.
Okay, now, go ahead and tear apart your Legos
Okay, 2 different.
into individual pieces. Yes, please.
What's the difference between two and
Don't put them up yet. Just leave them in the trash.
but so is the knot. Based on the
All right, now, the next question we're gonna answer is, what
They represent,
It just, in the simplest form,
they represent atoms.
they represent atoms. So these individual pieces represent atoms. You can make edits to your definitions if you need to. Okay, what do the different shapes and colors represent? What do the different shapes and colors, so look at your tray. What do these different shapes, what do these different shapes and colors represent? And if you need to group them so you can see better, do that. Not necessarily, but you can. What do the different shapes and colors represent? Mary Lou, you're up.
Different shapes and colors of each block in here represent different types of items.
Excellent, thank you. And I love the way you phrased your answer in a complete sentence, so people didn't even need to hear the question to understand what you were communicating. That's awesome. So, Mary Lou, can y'all quit moving for just a second, because Mary Lou she has some great things to share. Would you reiterate that?
Can you repeat the question then?
What do the different shapes and colors represent?
The different shapes and colors represent the different type of atoms.
The different types of atoms. Ashley,
Because you've got a lot of different things going on with them. You have different colors. You have different sizes or the pegs. You either have like a 2x4 or a 1x2, so those represent the different properties of the atom.
okay, could be.
Like the square one, the 2x2, and then you have the 2x3 that maybe that 2 wide or across could be one property, so they could be categorized together.
Okay,
Or if you, that.
you are going way beyond what I was thinking about when I put to group these together, but that's great. Okay, now I want you to build a molecule. Every single person, build a molecule. Look at your definition on what a molecule is and build one. Any molecule you want.
Pure.
You are building your own molecule.
It's not lining up with your.
Okay. Looks like we've got some molecules built. What type of molecule did you build? What type of molecule did you build? So look at what you built. Let's see. Brandon, what did you build?
I built a pure molecule.
You, what does that mean?
I had two atoms that's the same.
You had two atoms that were the same, so your molecule was a pure substance, you say?
Yes, ma'am.
Okay, all right, thank you. Pam, what did you build?
I built a 5 atoms of the same atoms to make a molecule.
Okay, so is that pure?
Yes,
Okay, all right, good. So it's pure because why is it pure?
because it only has one type of atom.
It only has one type of atom. Maria, what did you build?
Whenever it was said water molecule, it made me realize like it can be impure as well. I don't know if that's the right word, so I built H2.
Okay, so you built a water molecule and you knew, how did you know what to use to build it?
I just picked what color I wanted the H's to be, so H is
What is H?
hydrogen.
Okay.
So that
Okay,
would
and
represent
hydrogen is,
an atom or an element. So I picked 2 elements
you pick
and
two
I
elements
put them together.
and put them together to make
A molecule.
a molecule. Okay, awesome. One more, guys. Isabel.
Mine wasn't as complicated as far as mine was single, pure, 1, 2, 3, 4, of the same atom.
are giving me some great information. Could you
Together.
cohesively speak as a scientist?
Yes, I combined 4 of the same atoms to create a pure molecule.
Okay, great, thank you. Okay, so the question I want you to ask yourself, was your molecule, and some of y'all have already answered that, was your molecule made up of one type of atom? Was it a pure substance? Or was it made up of different atoms? So your molecule could be made up of one type of atom, a pure substance like Isabel's, or it could be made up of 2 or more types of atoms like Maria's. Raise your hand if your molecule was a pure substance. Okay. If your molecule is made up of 2 or more atoms, raise your hand. If your molecule is made up of 3 or more, 4 or more, 5 or more, Rochelle,
She just kept on building.
hold up your molecule.
Oh, different.
Wow.
So what's the difference for your molecule and compound?
Yeah,
Okay, we're
okay.
hold on to that confusion, because it's good. Okay, so, shoulder partners, what is it? Is what you created an atom, a molecule, or a compound?
I think this is a molecule. I think a compound is a type of molecule.
No, we're using some words that I know there's some confusion, and that's good, because we're gonna really understand this by the end of our lesson.
It's a molecule type.
It's a hierarchy. I think it's a hierarchy. So you have.
It goes like this.
Right?
So a compound can be a molecule, but a molecule can't be a compound.
So it wouldn't even be.
Molecule can be a compound, but a compound can't be a molecule.
Well, not all molecules are compounds.
I'm just saying, a molecule can be a compound, or compound can't be a molecule.
So it's not matter. You have it like this.
And this would be a compound with and then you have your own, which is
Okay, now, stop talking. Now, you're not gonna talk to your shoulder partner anymore, you're gonna talk to your face partner and explain to them whether yours is an atom, a molecule, or a compound, and why.
You have a matter, right? And then you can have a single atom. Just one. Then there are molecules. Yes. And then you have molecules, which can be compound, which is two or more different elements, or purely different, which has greater than one Well, a compound will always be a molecule. I mean, in the hierarchy of shapes, you've got polygons, which doesn't include a circle. Circle's not a problem. It's only one side. So multi-sided, and then you've got triangle, quadrilateral compound has multiple bonds, so forth and so on. So then you have that, you can try to solve a molecule compound that rectangle. So a square will always be a rectangle, not all rectangles. A compound will always be a molecule, not all molecules or compounds have three.
I'm wondering if it's I might be wrong.
You could have two molecules and when they come together, make a compound. I would think you only have one molecule. It turns into something like with photosynthesis.
Okay, guys?
You have H2O.
Okay, your name is coming up, so be ready to share your explanation what you built. Renee?
I built a molecule of one type of element.
What makes it a molecule?
Well, according to my previous definition, it means two or more of a single element, and it's two or more of a single element.
Okay, very nice, thank you. Rochelle?
Yes. I had a compound because it was made up of more than one different element.
Well, your instructions said build a molecule, so did you build a molecule?
Yes.
Okay, why does that make it a molecule? What makes it a molecule?
It makes it a molecule because I have one or more of a certain element. And then it makes it a compound because I have more than one molecule put together.
So how many molecules do you have there?
Five,
How do you know that it's 5?
because I counted them.
What are you
The
counting?
yellow one is one molecule of an element. The white ones are a second type of molecule of element. The black is a third type of molecule of an element. The green, the fourth, and the red, the fifth.
Okay. Kim, do you have some questions to ask Rochelle?
So.
Can I ask a question?
Please ask a question, help me,
So
throw me a line.
when we broke apart the Legos on your trays, what did we say that they represented? Okay, so if you had 10 pieces of white 4x4 blocks, what does that represent?
Pure molecule.
10 atoms of the same type, right? So if I took 2 of these exactly the same atoms, Kim,
If you built another section exactly like this, how many molecules would you have then? If you built another unit just like this, how many molecules would you have?
You're gonna do 10 or 2.
Why would you have, where's your difference? Explain to me your
If you're
difference.
trying to tell me that this is one molecule. Because it's like all put together, it's like one molecule. Or, so that would be the answer then would be 2. Or 10 because I still have one structure, but it still contains 5 molecles. So if I had 2 of them, that would make it 10. So I'm not sure
so
which one.
what you're saying, what I hear is that you're trying to decide whether it's the structure put together
That's
that
a
makes it a molecule,
Yes,
or if it's the types of pieces.
yes.
Okay, So, does anybody have a question they want to ask Rochelle for clarification? Candace?
Okay, so if you were to take apart the structure you have now,
Okay.
how many atoms do you have there? You have 11 atoms.
Cause atoms are individual.
Okay. How many how many, different, I haven't gotten,
Yeah.
How many pure
how many
substances?
different types of atoms do you have there?
Only 5 different ones.
Okay, so you have 5 different types of atoms and a total of 11 atoms there.
Right.
Okay, now I want you to build your structure again.
Well, something like this.
Can you hold it up so everybody can see it? So she took it apart into 11 individual bricks and then put it back together so it's all connected.
Okay, so you said before that once you took all of your bricks apart, those individual bricks represent
Atoms.
atoms, okay, individual atoms. When you put the structure together, you have what? Something,
So when I put it together,
is it a different structure than all of the little blocks?
Yes,
Blocks? Okay, so something brand new, you have a brand new
Something.
something,
Okay.
a new structure, right? Okay, now Kim said, why don't you build another of that,
Mhm.
right? So the individual bricks represent what?
individual.
Your 11
Atoms.
they represent individual atoms. What would that represent?
This structure.
That new structure,
I don't know. It's either, I'm still torn between a molecule, well, okay, this one structure, I guess it can't be a molecule because they're not the same. So I would go with the compound.
why?
Because according to my definition, it's more than one of different elements.
Okay.
And I have more than one different element.
Okay, so you've looked at individual atoms of different elements, cause you said that you had 5 different types of atoms when you
Mhm.
took those apart. And now you have a new substance that is made up of more than one type of atom, okay? And then what was the definition you had for molecule?
More than one of the same elements.
More than one of the same.
So if I had all of this white element, if I built this with only with white elements, that to me is a pure molecule.
Okay, can you think of, a substance that's made up of more than one type of atom that we use every day?
Can I think of a substance
A
with
substance,
more
more
than
than
one
one type
atom?
of atom that you're very familiar with?
Yes, Kim's H2O.
Okay, so water. Do you think that you can make a molecule of water?
Bam, done.
Okay, so now look at the models you made.
Okay, what are you calling this though again?
I said, do you think, Rochelle, that you can make a molecule of water?
You should have said yes.
You tricked me. No, this is. Okay, you're telling me this is a molecule then.
No, you told her.
No,
Oh,
you told her.
No, no, okay, I missed the molecule word, because then I would have told you to know that this is a compound.
Well,
According-
is it a compound, according to your definition?
More than, according to my definition, yes, because it's more than one different element.
Okay,
So
and
this
now,
is-
and I'm asking you, do you think that you can make a model that represents one molecule of water?
No.
Okay. Let's figure this out. You ready? Okay, so Rochelle, put that piece aside.
Mine?
Put your structure aside so we can come back to it, okay? Now each of you, make a simple molecule. Just a simple molecule, 1 or 2 pieces. Now I want you to replicate it as many times as you can according to the pieces that you have.
So like 4.
Go ahead.
Michelle, if you wanna make another one of those.
Is that a simple molecule? What's simple?
It's not pure. She just said something.
Why'd you put them together?
You told me to represent it.
That is, they put them together.
I'm gonna think. That's so awesome to mix it up. It's been a while since I've been on.
Yeah, if you run out, like Brenda's using 1 by 2 bricks of blue, but if there's very scarce on the blue, just use a different 1 by 2 blue. Just remember that it's supposed to be blue. Okay. Divide your pieces up into 3 equivalent groups. You know what, that's not gonna work, put those aside and just work with Melissa on her pieces.
Okay.
You're gonna need a lot of pieces for this, guys. And if there's not a lot, combine with a shoulder partner. You don't have to they don't have to be exactly
Sorry, I
the
was
same.
trying to separate so that we knew how many were in each one.
Wait, what are they doing? It isn't.
Okay, guys, listen. Okay, you guys here, like you combine yours, and you'll need to combine yours too. You need a lot of pieces, because you're gonna divide your pieces into 3 roughly equivalent groups. You can have 10, 10, and 9. They're just ish equivalent.
7 and 6.
So can y'all combine those? No, not connected, just grouped. There you go. Okay. Group 1. Put with your fingers, point to a group that you're gonna call group 1. Okay, and just so you know, you need a lot of pieces for this, like 5 or 6. So if you don't have enough, 5 or 6 different molecules. So if you don't have 5 or 6 in each group, combine with your face partners then. And group 1, I want you to squish those pieces as tightly together as you can.
So we don't have 5 or 6. I don't know if 5 or 6 pieces. I don't know if we have 5 or 6 pieces.
Mom.
So are you saying that this is a?
We have 4.
Are you talking like squish or smash?
Okay, you can. You may want to break apart that big tall blue one so that there's more along.
Oh, okay. Does anybody extra? 5 or 3 groups? You want 5?
Okay, so what I see you guys doing is, I don't want you to connect them. I want you to do that and then just squish them together.
Yeah, so
We're gonna break them down.
Squish them together.
I don't understand what it is.
Okay, squish. When I say squish, I mean slide them together in a horizontal manner. them,
Oh,
just move them together.
can you just say
Or
the
the molecules,
Compress them.
compress them. Okay, group 2. Okay, you were to divide your pieces into 3 groups. And then group 1, you're sliding them together, squishing them, compressing them. Group 2, move them together, but space them so that they are just barely touching. And they don't have to be all lined up like Brenda's in the orderly fashion. They can be haphazardly spaced, lightly touching. And then group 3. Group 3, I would listen please. Group 1 is when they're tightly packed together. Group 2, they're lightly touching. Group 3, I want them spaced apart so that they're not touching at all. So you have 3 groups of molecules. You've got molecules that are packed tightly together. You've got molecules that are just barely touching each other.